Hi, my name is Tara Donnelly, and I'm going to teach you about the electromagnetic spectrum. The electromagnetic spectrum is a range of frequencies and wavelengths of radiation ordered by amount of energy. On the left, we have radio waves, the longest and least frequent of the list. And at the far right, we have gamma rays, the shortest and most frequent of them all. Here are some examples of how long the wavelengths are to get some perspective. This can range all the way from big buildings to a small atomic nucleus. Here are some examples of what each type of wave is used for in reality. Radio waves are used for our actual radios. Microwaves are used to heat up the food in our microwaves. Infrared waves are used in radars. Visible light is everything we humans can see, meaning that it's responsible for all the colors we perceive. UV waves are used in some light bulbs and also come from the sun. X-ray waves are used for actual X-rays, and gamma waves are dangerous atomic radiation. So here's the visible spectrum. The visible spectrum contains all the colors in the rainbow, starting with red, the longest wavelength, and ranging to violet, the smallest wavelength. On either side of the spectrum are non-visible waves. The ones with lesser energy bounce off objects along with the visible spectrum. When waves have less energy, they have a lower frequency and therefore tend to have longer wavelengths. These tend to be used for communication, as radio signals and radars can be used to transmit messages. When waves have higher energies, therefore higher frequencies and lower wavelengths, such as ultraviolet, X-ray, and gamma rays, they can move through matter, including body tissue. This is why gamma rays and X-rays can sometimes cause mutation within the body. When such a wave hits an atom, the energy can allow an electron to become excited and move up a subshell. When the electron moves back down to the ground state, the energy is emitted as light. Each element also emits different wavelengths. This is called an emission spectrum, and it can be held in front of a heated element to show the different wavelengths coming off of it. As you can see, each element has its own unique wavelengths, and that's why this can be used to identify what an unknown element is. In addition to this, different heats of objects will give off different electromagnetic radiation. This can be used to identify the heat of things such as stars or comets in outer space based on their radiation. Thanks for watching.